These are the parts that connect the boom to the mast in a boat, and the part shown circled in red is the gooseneck, which is made of aluminum, while the triangular part that rides in a track in the mast is made of stainless steel. The aluminum part has worn out and is not working well for my friend, so he asked me to make a replacement. So this is the part that my friend wants to replicate, and as you can see, his design looks a little bit different because this part in the original had a slot down the back for some unknown reason. It also looks like it's a little open like that there. Obviously there's a pin going through here in the original, as I showed you in the earlier picture, but it really looks like it's been thrashed, and having something more substantial will be a real advantage for his boat, I think. So this is the chunk of stainless steel that my friend brought over. It's 316 stainless that he got from McMaster Carr. Ordered it one day and got it the next day, which was pretty impressive. Obviously this is the cut that they made in the warehouse, I presume. Pretty nice cut. So I have the stock centered in the vise. I'm just finding the end so I can locate that first hole. Here I am starting the center drilling process. Stainless steel needs high speed, as I have since learned, and a fair amount of lubrication. I'm squirting WD-40 on at this point. Now I'm drilling it out for the correct hole size. I'm using tapping fluid here, which I think is good, but boy, it sure smokes a lot. There's something I don't think I know about stainless steel, and I'm going to have to figure this out. But it's drilling through it fine. It's a very high quality drill bit, so so far so good. Now I'm centering the other orientation of this blank of stainless steel, finding the front surface, finding the rear surface, very carefully. There we are. So now I'm going to move over and find the end again because I relocated the blank of stainless steel in the vise. So finding the end. Then I can use my DRO to find the hole location. So here we are bumping into the end. Boom. There we are, center drilling that spot. None of this is very high precision, but I like to do it right. Just locate these holes precisely is just part of normal machining practice. So that's center drilled. Now I'm going to drill the full-size drill, again using cutting fluid, hoping that's the right thing to use for stainless steel. I hope none of you professional machinists are cringing too much. Obviously I'm using speeded up video here to save you all the boring and drilling stuff. It drilled out pretty nicely though. So now I'm test fitting the pin that belongs in there, and yes, that works just fine. That's a good fit. So now I'm going to cut off that piece, and hacksaws are for weenies, and I don't have a big horizontal bandsaw, so this is my go-to solution, just cutting it off directly with the angle grinder. So I'm going to go most of the way this way and then flip it over and cut the other half, and boom. So now I've chucked that back up in the vise, and I'm using my fly cutter, which is a high-speed steel fly cutting bit, and as you can imagine, I'm going to learn the hard way that high-speed steel and stainless steel are not particularly good companions here. So this is a second pass, and it got pretty smoky. The time-lapse kind of hides the smoky. Well, that attempt at fly cutting the surface was not great. I've actually flattened off the bottom edge of the cutter here, so I'm going to have to regrind that, which is no big deal. But another lesson learned, that high-speed steel is not good for stainless steel cutting. So now I'm using a 1/2-inch milling cutter to just face off the end. I thought that would be a good idea. It's cutting fairly well, and with a little WD-40, which produces a lot of smoke, I'm making a fairly nice cut here, although there's a lot of tear out and dross on the corners there. I took a moment there to sand off the corners, and I'm now trying to make the recess here. So I'm starting with a very shallow cut, maybe 20 thousandths, and as you can see, even with lots of WD-40 lubrication and spinning at very high speed, it's smoking like the blazes here. And one pass, maybe another pass, and I don't think this is going to work. This is working that little cutter too hard. It's a high-speed steel cutter that I got as a relatively cheap kit. Works fine for plastic and aluminum. So let me jump over here and try the angle grinder with the cutter in it, the thin blade cutter. I figure I'd cut a slot on each side and then maybe hollow the rest out. This is going fairly well. It's a good way to just relieve a bunch of material. So this is sort of working. So this didn't work out so well. As you could see, we were cutting slots in here to try and relieve a lot of the metal, and bound it up in one of the slots and chewed up the disc there. So, okay, do-over. Okay, plan C is to use a slotting cutter. This seems to be working fairly well. I started off using WD-40 as a lubricant, and then I switched to Viper's Venom, which I heard was a very good lubricant for this, and seemed to help a little bit. Here you see it now using the thicker Viper's Venom from my oil gun. A lot of smoke. Smells kind of weird, but you get used to it, I guess. The cutter felt like it was starting to work a little harder as I got further into this, and I didn't really look very closely at it, but it didn't seem right. So this is the slot cutter that I made as one of the first projects I did on my mini lathe, and it came out really well. I'm very pleased. The centering is really close. I mean, like 1 or 2 thou off at most, not even that. What's interesting, though, is that these 3 cutters that I got on eBay from some old guy date back to, let me see, 5/31/66. They came in the original wax wrapping paper. So I was really pleased to get 3 of these for like $20 or something like that. But the tips of this is just peened over, rounded over, wrecked. This is a replacement one I put on there already. But that was a really interesting lesson to learn again, you know, that while this cut really nicely at the beginning, it started to get more and more smoky and bogged down. And as I was turning the handles, I could feel it just getting harder and harder. So, yeah, this was an inexpensive lesson to learn, though. So having hogged out a bunch of that metal, I'm now switching back to my high-speed steel half-inch cutter head. And oops, yeah, I just forgot to tighten down the horizontal axis, so that it bumped over. Put it back into position, tighten the locking screw, and now I'm going to try and drive it through there and just tidy this whole cut up from the angle grinder and the slots, and just make it look a little bit better. And of course it's smoking like the blazes, and the handle wheel again is feeling stiffer and stiffer and harder to move. So as you could see, I was producing a prodigious amount of smoke as I was milling through this, trying to open this up, and I peened over the corners of this, and I was just basically burnishing the metal and using lots of lubrication. Yeah, obviously I've ruined my cutter. Another lesson learned here. So I sent my friend home with it as it was in an unfinished state, and he managed to clean it up quite nicely with his grinder. So it came out pretty well in the long run, but I had a lot to learn about working with stainless steel.